If you haven't already, please print out this handout so we can proceed. So at the top of the handout, you can see the title. We're talking about chemical equations. So the first word that we need to know is reaction. So a chemical reaction is a process that forms new substances with new properties. In previous grades, you may have looked at the terminology of a chemical change. It means the same thing. And there's 5 clues that a chemical reaction has taken place. You may have seen these in previous science classes. We also saw all of these in the demonstrations that I did in the previous video. So the first sign that a chemical reaction has taken place is if bubbles are formed. So we saw bubbles being formed. A lot of people ask about, is that true all the time? Well, you can think of the case of boiling water. If you have a pot of water boiling on the stove, bubbles are being formed. However, this is not a chemical reaction because there's no new substance taking place. That's just a change of state. So you have to be careful when you're looking at bubbles being formed. So that's why we have other clues that a chemical reaction has taken place. The next one is a color change. You can also have a new odor or smell, or a change in energy. So if heat or light is being produced or absorbed, or sound, any form of energy. And the last clue that a chemical reaction has taken place is if a precipitate is formed. Now we saw that happening in the demo, but basically it's a new solid that's being formed, that's coming out of solution. It's no longer dissolved in water. We will talk more about this one in later lessons. Chemical equations are used to communicate what is happening in a chemical reaction. It tells you what's going into the reaction and what's coming out. Reactants are the starting materials, and they appear on the left-hand side of the equation. Products are the substances that are formed by the reaction. They appear on the right-hand side of the equation. We'll get to that more in a little bit, but first, just a note about the kinetic molecular theory. It says that all matter is made up of particles which are in constant motion, and this motion is random. So there's all these particles just floating around, moving, crashing into each other. And that leads into collision theory. This is the theory that says in order for a chemical reaction to take place, these particles must collide. They must hit each other. And they must hit each other with the correct geometry and enough kinetic energy. So they have to hit each other at the right angle with enough energy in order for a reaction to take place. Now there's another item that we need to be familiar with in order to talk about chemical reactions, and it's this law of conservation of mass. It says that matter is neither created nor destroyed. So that means in a chemical reaction, there's no new atoms being formed, and we're not destroying atoms. Atoms are just being recombined. So the number of reactant atoms is the same as the number of product atoms. There's no new atoms being formed, they're just being recombined. And because of this, we must balance our chemical equations. We need to have the same number of atoms on the left as there are on the right. So now we'll proceed to talk about how do we write chemical equations, and then we'll proceed to talk about how do we balance them. So take a look at this bottom part of your note. Whenever we write a chemical reaction equation, we can indicate the state of each reactant and product. So what I mean is whether or not the chemical is a solid, a liquid, a gas, or aqueous, which means dissolved in water. So if the compound is a solid, we denote that with an S. If it's liquid, we use an L, gas is G, and if it's an aqueous solution, meaning dissolved in water, it's AQ. there's basically three ways we can write a reaction equation. The first is the word equation. That just means the reactants and the products are just shown by their name. So here we have an example of hydrogen gas reacting with oxygen gas to produce water. So we separate different chemicals with a plus sign, and the arrow indicates the direction that the reaction is proceeding. A skeleton equation, on the other hand, that actually shows the chemical formulas of the substances. So hydrogen is H2, oxygen is O2, and water is H2O. And we can indicate the state of each chemical. So I have hydrogen gas, oxygen gas, and liquid water. That's how I write my L's, just so you know, so that it doesn't look like a 1. And just some terminology on the right-hand side. The little numbers are called subscripts. Here, that indicates the state. And then we have something called a coefficient. And these are the numbers in front. And they tell us how many molecules of each chemical we need in order to have a balanced equation. So if I look at my example, on the left-hand side of the arrow, on my reactant side, I have 2 atoms of hydrogen. On the right-hand side of the arrow, so on my product side, I have 2 atoms of hydrogen. So I have the same number of hydrogen atoms on the left and on the right, so that's okay. That satisfies the law of conservation of mass. If I look at oxygen though, on the left I have 2 oxygen atoms, but on the right I only have 1. So if I leave my reaction equation as it's written here, it's saying that we're losing an atom of oxygen in this reaction. But we know that doesn't take place because we should have the same number of atoms on either side. So we need to balance this equation. We're going to write a balanced equation. I'll show you how I do it. So down here, I'm going to rewrite my skeleton equation. And what I do now is underneath the arrow, I write out all of the elements in my reaction. I have hydrogen and I have oxygen in this reaction. And then I count up on either side of the arrow how many I have. So I have 2 atoms of hydrogen and 2 atoms of oxygen on the left. On the right, I have 2 atoms of hydrogen and 1 atom of oxygen. So here I can see I need to have twice as many oxygen atoms on the right-hand side in order to balance them out. So I'm going to add a coefficient in front of my water and update my chart. So now I have my 2 oxygen atoms because I have 2 water molecules, but I also have doubled the amount of hydrogen. So I now have 4 atoms of hydrogen on the right. So I just balanced out my oxygens, but now hydrogen's not balanced. So I'm going to have to play around with the coefficient again. Now I'm going to add a 2 in front of the hydrogen, and now I have 4 atoms of hydrogen on the left-hand side because I have 2 molecules of H2. So now I look at my chart, I have 4 hydrogen atoms on either side, I have 2 oxygen atoms on either side. This is my balanced equation. And that's the basic principle behind balancing equations. Some equations get a little trickier to balance than others, but this is the general idea of how I do it. On this page, I've given you several word equations. I'd like you to take a moment, pause the video, and fill in the skeleton equations. So here I've given you the skeleton equations for each of those reactions. If you had trouble getting any of these formulas, I would encourage you to go back into Unit 1 about the nomenclature of these types of compounds, or you can email me with your questions. I'd like you to pause the video and try to balance these first 2 equations. So just the first two right now. Pause the video and try it on your own. Now, I'm hoping you were able to get this. If you didn't, then I would suggest you go back and practice again, or email me with questions. I want to show you something with the last two. Sometimes it's helpful when you have polyatomic ions, like here we have nitrate, here we have hydroxide, sulfate. When you are faced with these polyatomic ions, notice something. Here we have nitrate on the left, we still have nitrate on the right. Here we have sulfate on the left, here we have sulfate on the right. So the ion stays the same from the beginning to the end. So when we're listing out all of the elements included, why not just keep the polyatomic ion together? So instead of writing nitrogen and oxygen separately, just keep it as nitrate. It makes your counting easier. So we have 1 copper on the left, 1 silver on the left, and here's nitrate. How many do we have? Just 1. So we just have 1 nitrate on the left. On the right, we have 1 copper. Notice this. This 2 right here means there are 2 of whatever's in the brackets. So there's 2 nitrate ions. And we have 1 silver. So now balancing becomes a little easier. Copper and silver are good. I'm going to put a 2 here to adjust my nitrates, but it also changes my silver. So now I have to update my silver on the right hand side, and now everything's balanced. This last one is pretty much the same, except I want you to notice this one thing. Here we have hydroxide on the left, but you don't see a hydroxide on the right. So here's a little trick that I want you to notice. You can write water as hydrogen hydroxide. And again, that'll make your balancing a little easier. So we have aluminum, we have hydroxide, and hydrogen, and sulfate. We have 1 aluminum on the left, 2 on the right, 3 hydroxides on the left. How many on the right? Well, we have 1 water, so it's just 1 hydroxide. On the left, we have 2 hydrogens. And on the right, just 1. Sulfate, 1 on the left, 3 on the right. Now this one takes a little bit of back and forth, but you should end up with a coefficient of 2 on the aluminum hydroxide, a coefficient of 3 on the sulfuric acid, a 1 in front of the aluminum sulfate, and a 6 in front of the water. And that'll balance it out. Down below is just more practice with counting up atoms in compounds. So for example, if I look at this formula, Na2CO3, that subscript of 2 means there are 2 sodium atoms. Carbon, there's no subscript beside it, that means there's only 1 of them. The oxygen has a subscript of 3 beside it, so that means there are 3 oxygen atoms, adding up to a total of 6 atoms in this compound. Try the next 2, pause the video, see how you do. Start by listing out all the elements in each compound, and then use the rules of subscripts and coefficients to figure it out. Hopefully you were able to get this. If you have any questions about this, just send me an email and I'll get back to you.